Hello students, we are going to see last topic of the first chapter, which is inverse image of subsets under the function. Now let's see the first definition. Inverse image of subset. So first we will see definition. So definition of the inverse image of subset is that let F be the function whose domain x and codomain y, and B is any set which is subset of set y. Then we define inverse image of B under function f to be a subset that f inverse of B. Definition is f inverse of B is equal to set of all those x belongs to set x such that f of x belongs to B of x. That is, we say that pre-images of all the elements in B, the set of all pre-images of the elements in B, set of all pre-images of the elements in B, which is the definition. Means if B is subset of Y, then we say that f inverse of B is equal to set of all those point x belongs to set x such that f of x belongs to B. Now let's see the example. So I will take example f from a real number to a real number given by f of x is equal to x square. Then find f inverse of singleton 1 and f inverse of open interval 0 to 4. So to find this solution, so what is the definition? So what we have given here, f from what? A real number to a real number, and what is our function? F of x is x square. So we have to find inverse image of 1. So what is the definition? Now B is subset of y, then f inverse B is equal to set of all those point x belongs to x such that f of x belongs to B. So f of x belongs to B. So I will write it as definition. So here what is 1? So here set B is singleton 1. So B is subset of real number. So here B is equal to singleton 1, right? And which is subset of real number. Then what is definition? F inverse of B is equal to what? X belongs to x such that f of x belongs to B. So here P is singleton 1. So I will write f inverse of singleton 1 is equal to set of all those point x belongs to x such that f of x belongs to B. So B is here single point 1. So I will write f of x belongs to B means what? F of x is equal to 1. Here is single point. So I will write f of x is equal to 1. So which is equal to set of all those point x belongs to x such that f of x is equal to 1. So what is f of x? So x square is equal to 1. So which is equal to, so x square equal to 1 means what are the values of x which satisfies this condition? X is equal to minus 1 is equal to 1 and x is equal to 1 is equal to 1. So the values are x belongs to x such that x means what? Our domain is R. So I will write x belongs to R such that f of x is equal to B. So I will write here a real number R. So x is equal to what? X square is equal to 1. So x is equal to plus minus 1. Therefore set has element 1 and minus 1. So next what we have given? So first this is the inverse image of 1. Now we have to find inverse image of 0, 4. So here again B What is b? B is equal to open interval 0 to 4, right? Now to find inverse image, so inverse image of open interval 0 to 4 is equal to what is definition? X belongs to set of all real numbers such that f of x belongs to b. B means what? 0 to 4. So which is equal to set of all x belongs to real number r such that f of x belongs to 0 to 4 means what? 0 less than equal to f of x less than equal to 4, which is equal to x belongs to r such that here 0 less than equal to f of x means what? 0 less than equal to, here f of x is x square, so 0 less than equal to x square less than equal to 4. So here we know that x square always greater than equal greater than equal to 0, and here which is less than equal to 4. So I will write it as x belongs to r such that here x square greater than equal to 0. So this condition I will write this. And what is the condition? And what? X square less than equal to 4, right? So which, what we get here? So here x square greater than equal to 0, and here x square less than equal to 4. So we know that x square is equal to 4 means what? X is equal to what? Plus minus 2 means what will be the value? So x square less than equal to 4 means what? X lies between minus 2 to 2, right? So I get here x belongs to r such that here x square greater than equal to 0, and here what we get? Minus 2 less than equal to x less than equal to 2, right? Here negative square of negative number always positive means what? I get the only here x square less than equal to 4 means what? Here I write minus 2 less than equal to x less than equal to 2, because x square is equal to 4, then I get x is equal to plus minus 2 means what? The range of the function from domain of the function from minus 2 to 2, and square of negative number, suppose in real line here is minus 2 and here is 2 there, and square of negative number is again positive, so this condition is satisfied. Therefore values of x which is from minus 2 to 2, therefore the set has values minus 2 open interval close interval, sorry here open interval, so I will write strictly less than sign. So here again strictly less than, here again strictly less than, so I get here minus 2 less than x less than 2, so I get minus 2 to 2 is the interval. So which is the inverse image of the set 0 4, which is minus 2 to 2 under the function f of x is equal to x square. Now we will see some examples from exercise. Let's see whether find out whether the function f of x is equal to 1 minus x upon 1 plus x 1 1 and on 2. So we have to or check whether the function f of x is equal to 1 minus x upon 1 plus x 1 1 and on 2. If this function is 1 1 and on 2, then we say that the function is bijective function, right? So we will check this function which is 1 1 and on 2. So we have to check the condition if 1 1 condition for two ways. If we have f of x is equal to f of y, then to show that x is equal to y. And second condition, if x not equal to y, then show that f of x not equal to f of y, means you have to show this function is 1 1 by this way or this way. Now we will show that the function is 1 1, or check, we have to check function is 1 1 and on 2. So here f is from, so also given, so what is the domain of the function? So also given f from close interval 0 1 to close interval 0 1. So here domain of the function 0 1 and codomain of the function again 0 1. Now to check which is 1 1 and onto solution. So here f is from close interval 0 1 to close interval 0 1 and f of x is equal to 1 minus x upon 1 plus x. To check this function is 1 1 and onto. So here let I will take 2 points x y belongs to what domain 0 1 and if x not equal to y, if x not equal to y, then I will multiply by negative sign, means what minus x also not equal to minus y. So I will add 1 minus x not equal to 1 minus y. Also x not equal to y, if I add both sides by 1, then I get 1 plus x not equal to 1 plus y. So dividing this 1 by 2, what will I get? 1 minus x upon 1 plus x not equal to 1 minus y upon 1 plus y. So what will I get here? Here 1 minus x upon 1 plus x means what? Which is f of x, and here not equal to, here 1 minus y upon 1 plus y means what? I get f of y. So f of x not equal to f of y. So here I have taken x not equal to y and I get f of x not equal to f of y. Means what? Function is 1 1. F is 1 1. 1 1 means what? Injective function. Injective function. And onto means what? Surjective function, right? So we have to check second condition, onto. So for onto, so what is the definition for onto? For all y belongs to y, means y here is codomain, there exist x belongs to domain 0 to 1 such that, how to exist? Such that, so for all y means I will take any for all values of y from codomain, then there always exists value of x in domain such that y is equal to f of x. So y is equal to, what is f of x? Is 1 minus x upon 1 plus x. Now from this I have to calculate value of x and we have to check this value belongs to 0 to 1. So here we have to solve for value of x. So y into 1 plus x is equal to 1 minus x. So after solving for x, so y plus xy is equal to 1 minus x. So this value I will take left side. So y or xy, so here xy minus here minus plus x is equal to 1 minus y. So x into 1 plus y is equal to 1 minus y, which implies that I get x is equal to 1 minus y upon 1 plus y. Now here value of x. Now what we have taken y belongs to what? 0 to 1, and what will be the what is the value of x? I get here x, I get x is equal to 1 minus y upon 1 plus y. Now to check this value belongs to 0 to 1. So to check x belongs to close interval 0 to 1. So here if this belongs to 0 to 1, then we say that function is onto. But if x does not belong to 0 to 1, then we say that the function is not onto, right? So now to check x belongs to 0 to 1. So here what we have given, y belongs to 0 to 1. Here y belongs to close interval 0 1, means what? 0 less than equal to x less than equal to 1, sorry, here y 0 less than equal to y less than equal to 1. So we have to form this as 1 minus y upon 1 plus y, right? So here I will multiply both sides by negative numbers. If I multiply by negative numbers, then inequality will be changed. Means if I multiply both sides by minus sign, then less than equal to sign will be replaced by greater than equal to. Suppose I will multiply negative numbers, so 0 will greater than equal to minus y greater than equal to minus 1. Because if suppose I have 2 and 3, so what is the relation between 2? So 2 is less, sorry, here 2 is less than equal to 3, right? If I multiply both sides by negative numbers, then what will I get? So here, or I will write here, I will compare, suppose here minus 2 and here is 3. So minus 2 is always less than equal to 3, right? 3 is greater than equal to minus 2 always, right? If I multiply both sides by minus sign, then what will I get? Minus minus plus 2 and here minus 3. So between these two numbers, which one is greater? So 2. So which is greater than equal to, means what? If I multiply by inequality by negative numbers, then less than equal to sign replaced by greater than equal to sign, and greater than equal to sign replaced by less than equal to, means inequality will be changed. So here I get, now I will write it as this direction, means minus 1 less than equal to minus y less than equal to 0, right? So this can be written in reverse way, means here minus 1, so less than equal to minus y less than equal to 0. So we want 1 minus y, so add throughout 1, so I get 1 minus 1 less than equal to 1 minus y less than equal to 1. So 0 less than equal to 1 minus y less than equal to what? 1. Again, also what we have to find 1 plus y. So 0 less than equal to y less than equal to 1. I will add throughout by 1. So what will I get? 1 less than equal to 1 plus y less than equal to 2, right? So here 0 less than equal to 1 minus y less than equal to 1, and here 1 less than equal to 1 plus y less than equal to 2. Now divide 1 by 2. So this is equation 1 and this is 2. Divide 1 by 2. What will I get? So 0 less than equal to 0 upon 1 0. So 1 minus y upon 1 plus y. So 1 minus y upon 1 plus y less than equal to 1 upon 2, right? Here what we get? So 1 upon 2 always less than equal to what? 1, right? So 2 upon, sorry, 1 upon 2 means 1 upon 2 means value 0.5, always less than equal to 1, right? Means I will write it as 0 less than equal to 1 minus y upon 1 plus y is strictly less than equal to 1. Means what we say that this value is nothing but value of x. So 0 less than equal to x less than equal to 1 means x belongs to what? 0 to 1. Means what we have to say here? X belongs to close interval 0 to 1. Means here x belongs to 0 to 1 means what we say? F is onto. Therefore f is onto function. Therefore f is onto function. Therefore f both is 1 1 and onto, hence both this function is bijective function, right? Next example is, let f is from R to R defined by f of x equal to twice x plus 1. Then find out first image of 1 3, second one image of open set 1 to close 3, third image of close equal to 4 intersection minus 2 1 open interval, and last f of minus 1 2 union 1 4. Here is close interval open. So we have to solve this. Solution: what is given function? So our function is twice x plus 1 and we have to find image of a subset. So what we have here, f is from a real number to real number defined by function f of x is equal to twice x plus 1. So what is the definition of image of a subset? If f from x to y is subset or is f from R to R or x to y is a function and a is subset of x, then what is the definition? F of a is equal to set of all those y belongs to or f of a such that a belongs to set A. This is the definition for in image of a subset where A is subset of X. A is subset of X. So here in first example, so here A is equal to what? Set 1 3, right? So 1 3 which is subset of a real number R. Therefore image of A set 1 3 which is f of a. So here f of a means what? A belongs to set A. So what are the points of A? 1 and 3. So I will write f of 1 and f of 3 which is equal to, so f of 1. So our f of x is twice x plus 1. So put x is equal to 1 in this equation. So I get 2 into 1, 2 plus 1 which is 3 and f of 3. So after putting this value 3 into 6 plus 1 7. So the image of set 1 3 which is 3 7. Now next second one f of open 1 to close 3. So second to find image of f of 1 to close 3. So what is the definition? Which is equal to set of all here function f of 1 f of 3 close interval. So what is f of 1? So f of 1 is 3 and f of 3 is 7. This is open 3 to close 7 because here we have given the interval and here is the set. Curly bracket has element 1 3 here, interval 1 3. Now next third one what we have given. So here set A is close to 4 intersection minus to 1. So our definition is f of close interval to 4 intersection minus to 1 which is equal to, what is the definition? Here close interval images image of f of 2 comma f of 4 intersection image of f of minus 2 comma f of 1. So here is open interval. So which is equal to, so what is f of 2? Here our f of x is twice x plus 1. So replace value of x by 2. Then what will I get? Here if I put x is equal to 2, then 2 into 2 4 plus 1 5 and here is f of 4. F of 4 will be 4 into 2 8 plus 1 9 intersection f of minus 2. If I replace x by minus 2, so minus 4 plus 1 which is minus 3 and f of 1 will be 3. So here intersection is given. So intersection means the common points between these two sets. So here I have the real line, right? So this is y axis and this is x axis. Here is suppose minus 3 and here is suppose minus 3 and here is 3. So here is 5 and here is 9. So first our 5 to 9 set is here and minus 3 to 3 is here. So there is no common point between these two sets. So intersection will be empty, right? Now last one f of minus 1 to union 1 4. So last D here f of minus 1 to union what close interval 1 to open 4. So which is equal to, I will write it as images of what? Image of f of, so here open interval f of minus 1 comma f of 2 union f of 1 comma f of 4. Here is open interval. So which is equal to, what will I get? F of minus 1. So minus 1 means 2 into minus 1 plus 1 which is minus 1. Next f of 2. 2 into 2 4 plus 1 5 union, here is close interval, and here f of 1 is 3, and here f of 4 is 2 into 4 into 8 plus 1 9, open interval. So here is union, right? So I will write on real line. So here is, suppose here is -1 and here is 5. So this is the set first, -1 to 5. The next interval is, here is suppose 3 and 9. So this is the second interval, and union is the set of all point which is belong to at least set, this set or this set, means this is the all points which the covered by two sets. So union of these sets will be from -1 to 9. So here interval, open interval. So here -1 to open interval 9. This is the image of subset f of -1 to 2 union close interval 1 to 4, which is -1 to 9. Let's see another example from exercise. Find inverses of following bijective functions. Find inverses of following functions. So first function is f is from close interval 0 infinity to close 0 1, and defined by f of x is equal to x upon x plus 1. And I will take second function, f is from closed interval 0 1 to closed AB, where a strictly less than b, defined by f of x is equal to a into 1 minus x plus bx. Now what we have to find here? Find inverses of the function defined by relation f from close interval 0 infinity to open 0 1, defined by the function f of x is equal to x upon x plus 1. Now when inverse of the function exists, if function is both 1 1 and onto, means bijective function, then inverse of that function exists. Now first we have to check the function f of x is equal to x upon x plus 1, which is 1 1 and onto. Then we have to find inverse. So solution, now to check the function is 1 1 and onto. So here first f is from close 0 infinity to close 0 1, defined by the function f of x is equal to x upon x plus 1. To check f is 1 1, so I will take 2 points x y belong to 0 to infinity, and if x not equal to y, then I will write, if I add both side by 1, then what will I get? So x plus 1 also not equal to y plus 1. Divide these two equations 1 by 2, then what will I get? X upon x plus 1 not equal to y upon y plus 1. So this is f of x. So here f of x, and here is f of y. So this is not equal. So this is also not equal. So f of x not equal to f of y. Here x not equal to y, and I get f of x also not equal to f of y. Means what? F is 1 1. F is 1 1 function. Now f is 1 1 means, or we say that it is injective function, right? Now next we have to check the function f of x is equal to x upon x plus 1 is onto. So for onto function, what is the definition? For all y belongs to codomain, so codomain is 0 1, there exists x belongs to 0 to infinity, such that how to exist? Y is equal to f of x, which implies that y is equal to, what is f of x is? X upon x plus x. So y into x plus 1, which is equal to x. So which implies that, so x into y plus y is equal to x. I will solve for x, which is equal to x y minus x is equal to minus y, which implies that I will take x as common. 1 y minus 1 is equal to minus y. So finally I get x is equal to minus y upon y minus 1. So I will take minus 1 common on denominator. Then minus 1 and 1 will get cancelled. So remaining I get x is equal to y upon 1 minus y. Now here x is equal to y upon 1 minus y. So here y belongs to 0 to 1, and we have to check this value belongs to 0 to infinity. If this condition satisfy, then we say that the function is onto. So to check x belongs to 0 to infinity, so here if I put value of x is equal to 1, sorry, y is equal to 1, then I get 1 upon 0 means what, which is infinity. So x belongs to 0 to infinity, right? So if I put value 0, when y is 0, then I get 0 upon 1, which is 0, which belongs to whole set. X belongs to 0 to infinity means what, which belongs to closed 0 to infinity. Therefore function f is onto. Here function 1 1 and onto means what, therefore function f is bijective function. F is bijective function means inverse of function exists. Therefore inverse of function exists. So I will write this is equation number 1. And inverse of function exists means what, f of x is equal to y. So I apply f inverse on both sides. So I get here x is equal to f inverse of y. So using this value in equation 1, what will we get? Here using this value in equation 1, so f inverse of y is equal to y upon 1 minus y. This is the inverse of given function f of x is equal to x upon x plus y. Now second example, to find inverse of the function f of x is equal to a into 1 minus x plus bx, where we have defined function from 0 1 to closed ab. Now let's see second solution of second b. Here f from closed 0 1 to closed ab, here a is strictly less than b, defined by f of x is equal to a into 1 minus x plus bx. To check this function is 1 1 for 1 1 function, because we have to find inverse, and inverse of function exists if function is bijective function, means function is 1 1 and onto. So first check 1 1 function. So let I take x y belongs to domain 0 to 1, and if x not equal to y, then so I will write multiply both sides by minus 1. So minus x not equal to minus y. So multiply, so add both sides by 1. So 1 minus x not equal to 1 minus y. So multiply by a. So a into 1 minus x not equal to 1 minus a into 1 minus y. Again what we have, so x not equal to y, then I will multiply both sides by b. So bx not equal to by. So adding particular side, what we get, a into 1 minus x plus bx left side not equal to a into 1 minus y plus by. So this is function f of x. So f of x and here is f of y are not equal. Here x not equal to y, I get f of x not equal to f of y. Therefore f is 1 1 function, 1 1, or we say injective function. Now to check function is onto. So for onto function, what is definition? For all y belongs to codomain. What is codomain? Closed AB. Then there exists x belongs to 0 1 such that, how to exist, f of x y is equal to f of x. So y is equal to f of x is a into 1 minus x plus bx. Now to solve this for value of x, so I get a minus ax plus bx, which is y. So I will solve it for value of x. So y minus a is equal to, I will take a as x as common, so b minus a. So x is equal to y minus a upon b minus a. Now here for all y belongs to closed AB, then we have to find x belongs to closed 0 1. Means we have to check that this belongs to 0 to 1 or not. Now to check, now what we have given, now here a less than equal to y less than equal to b. Now to check y minus a upon b minus a belongs to 0 1. So I will adjust like this, means I will subtract throughout by a, so I get a minus a less than equal to y minus a less than equal to b minus a. So 0 less than equal to y minus a less than equal to b minus a. Divide throughout by b minus a. What will we get? 0 less than equal to y minus a upon b minus a less than equal to 1. So this value belongs to 0 to 1, means this value is value of x. So 0 less than equal to x less than equal to 1, means x belongs to what? 0 to 1. So this value belongs to what? 0 to 1, right? Means, so for all y belongs to closed AB, there exists x belongs to 0 to 1, means what? Function is onto. That implies f is onto function. Here is function both 1 1 and onto, therefore inverse of function exists. Therefore what we say here, therefore f is 1 1 and onto, that implies f is bijective function. F is bijective function, then we say that is like inverse of function exists. Inverse of function exists. So what will be the inverse? So y is equal to f of x. So I will apply by inverse, then I get f inverse of y is equal to what? X. I apply f inverse, means f inverse y, f inverse of f will be identity. So f inverse y is equal to x. Using this value in equation 1, so this is equation 1. Using in 1 equation 1, so what will we get? X is equal to what? F inverse y. So f inverse of y is y minus a upon b minus a, which is the inverse of given function. Now, so here our chapter is completed. Now in next lecture we will start second chapter, divisibility theory in the integers.